Hello everyone, and welcome back to the Fluctus Channel. Air dominance and deterrence is an important part of the doctrine of the U.S. military. Therefore, the U.S. Air Force has fielded some of the best strategic bombers ever made. These range from the first pressurized cabin B-29 that dropped nuclear bombs on Japan to aircraft that are invisible to radar detection, like the B-2 and the old and reliable B-52. Nazi Germany already saw the potential of the flying wing design with the Horten HO-229. Modern stealth bombers, such as the B-2 Spirit and the B-21 Raider, use modern classified technologies to escape detection. Their flying wing design, radar-absorbent materials, and specialized coatings greatly reduce radar signature. These aircraft can penetrate advanced air defenses to deliver conventional and nuclear missiles, and they fly largely at night for added concealment during strategic bombing operations. Since the B1B Lancer is getting old, it is feasible that the new B-21 Raider will replace it in the future. Until such a time, the B-1B Lancer remains one of the best bombers in the U.S. Air Force and Europe. It is smaller and has a lower radar cross-section than the old B-29 and B-52 bombers. Thanks to its blended wing body design and swept wings, the Lancer is much more maneuverable and can fly at supersonic speed.
When tensions rose with the Soviet Union, especially with the Berlin blockade and the subsequent airlift, we didn't have the forces in theater to necessarily respond on the ground, so to speak. So one of the ways we could do that was with strategic air power. And leaders in America and the UK decided we needed that reassurance. We needed some capability in Europe to be able to respond if tensions with the Soviet Union escalated.
Realistic maintenance training on the B-1B is performed using various methods, including a trainer aircraft. The B-1B Spectre 86-109 was converted to a maintenance trainer at the EDMX Training Center. After being decommissioned from active duty, the F-101 engines, essential avionics systems, and miscellaneous components were removed and used in operational aircraft. Because of the B-1B's variable sweep wing design, removing these heavy components could cause stability issues. Two 2,640-pound counterweights were fitted to compensate for the lost engine weight, keeping the aircraft from becoming tail-heavy and maintaining stability during ground handling and training sessions. This balance is critical since the swept wing configuration changes the aircraft's center of gravity. Since its introduction in 1986, the B-1B Lancer has become an old airframe. For that reason, parts are not readily available. At bases such as Ellsworth Air Force Base, they produce their parts in technologically advanced fabrication shops. Ellsworth AFB's maintenance facilities use cutting-edge manufacturing technology, such as CNC machines, precision lathes, and industrial 3D printers to create replacement B-1B parts. The machine shop has multi-axis milling machines, EDM, or electrical discharge machining systems, and modern welding equipment. They also use coordinate measuring equipment for quality control and reverse engineering capabilities to replicate parts that are no longer in production, assuring fleet sustainability through in-house manufacture. Upgrades such as the Battle Station upgrade have retained the Lancer as a force to be reckoned with more than 3 decades later. The Battle Station upgrade for the B1B Lancer significantly improves its Offensive Systems Operator, or OSO, and Defensive Systems Operator, or DSO stations. The update replaces previous monochrome panels with modern full-color monitors, improving situational awareness and targeting capabilities. With new ergonomic controls and improved software interfaces, crew members may process information more efficiently. The upgrades include improved digital mapping, threat detection displays, and weapon management systems. This update smoothly interacts with the aircraft's existing defensive and offensive systems, leaving room for future upgrade opportunities. The Battle Station dramatically increases crew effectiveness and mission capabilities in modern combat circumstances.
Since World War II, we have held global air superiority. And with the IVS upgrade, this jet will help us remain it, or keep it for years to come.
Before any flight, the aircraft needs to be checked. B1B pre-flight maintenance includes extensive system tests and service. The maintenance staff thoroughly inspect all 4 F101 GE102 engines, including the oil levels, fuel systems, and intake exhaust areas. They test the hydraulic systems for the variable sweep wings and flight controls, examine tire conditions and pressures, and assess the fuselage for structural integrity. Diagnostics of radar, communications, and weapon systems are all part of electronic system testing. Environmental control and pressurization systems, as well as emergency and ejection seats, are tested. Crew members also conduct FOD, or foreign object damage walks, to ensure the flight line is clear. All inspections are documented using stringent Air Force technical directives and checklists. Engines require special care. The B1B's F101 GE102 engines are tested in specialized noise suppression facilities known as hush houses, which contain and attenuate the loud sound of engine operation. These enclosed buildings enable maintenance personnel to operate engines at full power while conducting diagnostic testing and maintenance checks. The facility has improved acoustic treatment, adequate ventilation systems, and unique thrust containment. In a controlled environment, technicians can measure engine performance data such as thrust output, fuel flow, temperature, and pressure. The Hush House has fire suppression systems and emergency shutdown capabilities. This controlled testing environment ensures proper engine operation while safeguarding personnel and the surrounding region from noise pollution and jet blasts. Certain munitions for the B-1B require significant preparation. The B-1B's quick-strike naval mines are assembled in specialized munitions facilities. The process begins with Mk-80 series bomb bodies being converted into mines using specific mine conversion kits. Technicians use the Munitions Assembly Conveyor, or MAC system, to safely and efficiently move components through the buildup process. The conversion includes installing mine-specific fusing, sensors, and target detection devices. Each mine requires precise assembly of its activation and detonation mechanisms. Environmental seals are critical due to the mine's maritime role. Quality control checks occur at multiple stages to ensure proper assembly and arming sequences. Due to the sensitive nature of the mine components, strict safety protocols govern the entire assembly process. Once the particular munitions are ready, they need to be loaded. When loading weapons, like the GBU-31 Joint Direct Attack Munition, or JDAM, into the rotary launcher assembly of the B-1B, USAF munitions technicians use precise techniques. The process begins with a comprehensive evaluation of the weapon's components, such as lugs, data plates, and the guiding kit. Following verification, the munition is loaded using the MHU-83 jammer, which can handle weapons weighing up to 2,000 pounds. Teams meticulously align the JDAM with the BRU-56 bomb rack using predetermined checklist procedures. The weapon is next attached to the rack, after which weight and movement checks are performed to ensure appropriate attachment. Stabilization mechanisms are fitted to keep the launcher stable during rotation. This entire procedure involves precise coordination among team members while once again adhering to strict safety protocols. Getting ready for flight is a long process. B-1B aircrew begin with a full mission briefing that includes weather, missions, and emergency procedures. Crews put on their flight gear, which includes anti-exposure suits, G-suits, and survival vests before collecting helmets and breathing masks. They conduct equipment checks and assess their emergency oxygen systems. After arriving at the aircraft, they conduct external walk-around inspections while maintainers do final checks. The crew climbs aboard via ladder, straps into their ejection seats, and connects the oxygen and communication equipment. They then go through the pre-start checklists, system initialization, and engine start procedures before seeking permission to taxi. After taxiing, the crew prepared for takeoff. After getting clearance, the B-1B crew lined up on the runway centerline and adjusted the takeoff trim. After clearing the tower, they increased all 4 throttles to maximum power while checking engine parameters. Once stabilized, they engage afterburners sequentially, producing immense thrust with distinctive flame rings. At the calculated speed, the pilot eases back the control column, rotating at around 145 knots. The big bomber takes off instantly, elevating its landing gear and flaps in accordance with the ascent schedule. Afterburners remain engaged during the first climb out until they reach a safe height and speed, at which point they are successfully retracted. The airplane then accelerates to its cruise climb speed.
The B-1 is the only supersonic bomber in the Air Force inventory, and we can reach speeds up to 1.2 Mach.
Lancers can launch various types of munitions, including retarded bombs, at low levels. During low-altitude bombing runs, the B-1B can drop many delayed bombs in succession, with drag chutes slowing their descent, so that the aircraft can safely escape the blast radius. The bomber normally releases its payload while flying at 500 to 600 feet and utilizing terrain following radar. Defensive flares are automatically emitted during the bombing run to deflect any heat-seeking missiles, as the aircraft is particularly vulnerable at this point. The low-altitude delivery produces a distinctive walking explosion pattern as bombs impact consecutively, while the B-1B's afterburners ignite for quick departure from the target area. While the future of strategic bombing seems to lie with stealth aircraft like the B-21 Raider, aircraft like the B-1B Lancer remain a potent force in the U.S. inventory. While the B-1B is an old airframe, careful and detailed upgrades and maintenance ensure it will continue flying for decades to come. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.